This is Miss Downey, and I'm going to take you through Algebra 2, Chapter 2, Study Guide. Problem 1 says, make a mapping diagram for the relation. We've got a set of coordinate pairs, x and y, x and y. So you want to make a column for the x's with all the x points, and a column for the y with all the y points. Okay, like such. Here's my x, there's my y. Next, you want to map them. So negative 2 goes to 6, 0 goes to negative 3, 1 goes to 4, and 3 goes to 3. And that's your mapping diagram. Number 2 says find the domain and range of the relation. Well, domain is just our x values, and the range is our y values. These are just points. So you're going to get all the coordinate points for all 5 of these. And now your x values are just, your range is just your x values, negative 3, negative 2, 2, I'm sorry, that's negative 3.5, 3.5, and 0. So your domain are those points. And your range are all the y values. So 3, 3, and notice you listed only once, 1.5, 1.5, listed only once, and a negative 0.5. So there's your domain and range. Number 3 says find the domain and range of the relation and determine whether it's a function. Well, we can use the vertical line test and see that it is definitely a function because it's only crossing in one point. So we already know, yes, it's a function. Now what's the domain and range? This is a continual line, and if the graphic was correct, they'd be going on forever and ever and getting very close to these boundary lines here and here. So if we look at this, we see that for your x values, which is your domain, the x values, so look at what the x value is doing. So it looks like it gets very close to this number as it goes on up to infinity, but it never quite touches, and so that is 3. So we're going to say that it's going to begin at 3, but it never equals 3. So we're going to say for the domain, x is greater than 3. And see, it would go on and on and on forever and ever and ever to positive infinity. So that would be it. Your domain, x is greater than 3. Now, for the range, we have to look at our y values. So the range is our y values here on the y-axis. So when we look at this graph, we notice that, okay, does it hit 0? Not quite, but it does hit 1 and 2 and everything past 0. So for our range, we can say that y is greater than 0. And that's your answer. 4, for each function, what is the output of the given input? So they want to know for f of x equals 5x plus 4, find f of negative 4. So we're going to say, well, f of negative 4 is equal to the 5x plus 4, right? And everywhere there's an x, we're going to now replace it with a negative 4. So 5 times negative 4 plus 4, which is negative 20 plus 4, which is negative 16. So f of 4 is negative 16. 5, determine whether y varies directly with x. If so, find the constant variation of k and write the equation. So we have to do our comparison of y over x. So we're going to go 2.8 over 2, 7 over 5, 11.2 over 8, and 15.4 over 11. So when you divide all these out, you find that they're all equal to 1.4. Because this is a constant change, this is a direct variation. This is all the same number. So that becomes our k value. So we know a direct variation is y equals kx, and this is our k value, 1.4. So our equation is y equals 1.4x. And that's our answer. Determine whether y varies directly with x. If so, find the constant of variation k. So we have 2y equals 5x. We need to make it look like y equals kx. So we're going to try to isolate y. So divide each side by 2. When we do, that cancels out. We get y equals 5 halves x. It looks just like our equation. So yes, it's a direct variation, and that is our k. So k is equal to 5 halves, and that's our answer. Number 7 says, the table shows the median home prices in Florida. What is the equation of a trend line that models a relationship between time and home prices? So that's the first part, to find the equation of a trend line. So we have to get a trend line first, modeling that relationship. Then we need to use that equation to predict the median home price in 2030. So I've added this orange line right here that says use this for time. When you look at what they gave us, year and median prices, they gave us 1940, 50, 60, 70, 80, 90, and 2000. Well, we have to predict into 2030, so we could go ahead and expand that to 2010, 20, and 30. All right. The median prices are associated, written there, and unknown for 70, 80, and 90. So let's start with first things first. What is an equation of the trend line that models this relationship? So we have to plot these. Because they're telling us to write a trend line, it's obvious that there's not going to be a direct variation where these have a constant slope. So we have to plot all these points and create our line of best fit. So we know we're looking for an equation y equals mx plus b, right? And if we look at this, we start with 1940 for our year. So we're going to let that equal year 0. And 10 years later, at 1950, that's 10. And 60 is 20, 70 is 30, and so on and so forth. And remember, they ask us for the price in 2030, so I went ahead and continued. 2010 would be 70, 80, 2020 would be 80, and 2030 would be 90 years later. So let's plot the points that they gave us. Okay, so using 0, 10 through 60 and our median home prices, we're going to plug these in right here. And when we do, it plots them over here. Okay, and this automatically generated the line of best fit. And if we notice, we're looking for that y equals mx plus b. Formula. And we know that b is our y-intercept. We have a y-intercept. We already know that, right? It's the 20,900. So let's replace b with 20,900. Now all we have to do is find the slope and calculate our price. So let's find something close on our line of best fit to calculate our slope. So when you look at these, I'm looking for one that's on a perfect crosshair. Well, we can use our first point, and I'm just going to estimate that to be 20,000, right? And up to here. So let's count our rise and run. Now remember, these are in tens of thousands. So this is 10,000, 20,000, 30,000. So I have a rise of 30,000. And my run is going to be across my time. It's in increments of 10. So we're going to go 10, 20. So I have 30,000 over 20. Well, when you simplify this, knock off a 0 there, and I have 3,000 divided by 2, which is 1,500. So I've got a slope of 1,500. Okay? So I'm going to put that in here. All right, now there's my line of best fit. Now I've created the first part of our question. What is an equation of a trend line that models the relationship between time and home prices? So there it is, y equals 1500x plus 20,900. The next part says use the equation that we just wrote to predict the median home price in 2030. So we already talked about how in 2030 that's going to be 90 years away. So we're going to plug in 90 for our x and calculate. So let's get our calculator, and I'm going to say 1500 times 90 equal 135,000. And now we're going to add to that 20,900. So the median home price in 2030 will be 155,900. And that is your answer. All right. And that's your answer. I want to add a point here. Remember, you're taking a multiple choice test, and this is some sample answers that you could get on your test for this particular problem. Now remember, you were estimating a line of best fit, and everybody's estimations might be slightly different. But if we look at this, let me pull my answer down here. Oof. There we go. So when first I calculated the slope, the first thing we knew for sure was the y-intercept, 20,900. And you notice that all four of those had 20,900. So that would have been no help to help us get our answer. So when we calculated slope, we had 1,500. All right, notice what you have for all four of these slopes. You have 1,500, 45, 1,500, 45. So we only had a very large number, 1,500, or a smaller number, 45. Even if you were off on this line by a little bit, having these two numbers to choose from, it would have been very easy to pick the 1,500, the bigger number, over the 45. So that would have helped you eliminate B and D. And at that point, you would say, well, I'm going to use the slope. Here's my equation. Now I need to plug that 90 in to this equation and see if I get 125,900 or 155,900. And we got the 155,900. So the answer would have been C. Number 8 says, let g of x be the reflection of f of x equals 2x plus 3 in the x-axis. What is the function rule for g of x? Well, we need to start by doing first things first, which is let g of x be a reflection of f of x. And we know f of x is equal to 2x plus 3. And they want it to reflect over the x-axis. Well, if it's reflecting over the x-axis, that means your y values are being opposite. So our formula for that was g of x equals negative f of x. Now we're going to start by writing our information. F of x equals 2x plus 3, and our reflection rule, g of x equals negative f of x. Okay, and here's my little depiction. If I have a value up here and I'm reflecting it over the x-axis, now that value becomes a negative value. That's why we do the negative f of x. So now we're going to substitute our f of x in, keeping our negative value. So negative, and what is our f of x? 2x plus 3. So put that in, and now simplify. So negative 1 times all of 2x plus 3 becomes negative 2x minus 3. So our new function is g of x equals negative 2x minus 3. Number 9 says write an equation for the following transformation of y equals x, a vertical stretch by a factor of 4. So we know if we have y equals x, okay, that is just like a y equals 1x plus 0, right? That means we've got an equation that's going through the origin, y-intercept of 0, right, with a slope of 1. So rise 1, run 1. There. Rise 1, run 1. And it's going to be that line that bisects the first and third quadrant. Now, they want us to take this and give it a vertical stretch of 4. So we know that that's just changing our slope to 4 over 1, right? So the a value goes in front of the x. So it's y equals 4x. So we have tilted our slope to rise 4, run 1. So our new line is going to do something like that. That would run through the origin. Okay, and that's what a vertical stretch does. Our next problem, number 10, says the function f of x equals x squared. And I've drawn it roughly right here. So that is that parent function of a parabola for the quadratic. Right? The graph of g of x is f of x translated to the right 2 units and up 6 units. So they want to shift it this way by 2 and up 6. And that's our new g of x. All right, and what is the function rule for g of x? So we know it's going to go to the right 2. So that's going to be y equals x squared, and we're going to shift that to the right 2, so it's a minus our h, and then it's going to go up 6. So it's going to take us, let's see if I can grab this. Oops. Over 2, 1, 2, and up to 6. So our new line is right there. Okay, and oh, that was our g of x. So let's fix that. Okay, and that's your answer. Number 11 says, what transformations change the graph of f of x to the graph of g of x? So f of x, we have x squared. And g of x, we have, it's equal to x plus 3 squared minus 5. So we see that original formula, right? This would be our x squared. So what did we do? We have done a plus 3. Well, the original formula is x minus h, right? So this, our h must be a negative 3. So this is going to be our h equals a negative 3. So we've moved this horizontally 3 units backwards and down 5 units. with our negative 5. Okay. Number 12 states, what is the graph of the absolute value equation? Well, we know the parent function is right here. Oops. I need to do that. Right here. And now we're taking the absolute value, y equals absolute value of x, and we're shifting it up 3 units. So the new one will look like that. So we just took the parent function and shifted it up by 3 units. Now I want to take a moment to point out the parent functions one more time. Of a linear function, it's just y equals x. And y equals x squared, that's the quadratic. It makes the parabola that does this, and it intersects at the origin. And then the absolute value, y equals absolute value of x, makes the v that runs through the origin. And those are important to know. Number 13 says we've got to describe or pick out a graph from y equals absolute value of x minus 2. Well, what is that minus 2 doing? Well, it says we're moving to the, if it's going minus 2, we're moving to the right 2 units. So the red v was our parent function, and shifting that parent function to the right 2 units takes us to the blue function. Number 14, you have y equals absolute value of x plus 1 minus 2. So the plus 1 is going to shift the v to the left 1, and the negative 2 will shift us down 2. So it's going to go from that parent function that's up here, so to the left 1, and then down 2. 15, now we have y equals absolute value of x plus 3 minus 4. So we know our horizontal value is negative 3, so we're shifting back 3, and we're going down 4. That'd be back 3 and down 4. So there's our new location. So you take your v, and we're going back 3, 1, 2, 3, and down 4, 1, 2, 3, 4, to our new vertex. On 16, we have y equals 5 times the absolute value of x. So we're going to take that parent function, right, and we are going to stretch or compress because we have an a value here. Well, that's a 5, and it's greater than 1. So this is a stretch. So we're going to stretch this by a factor of 5. Oh, it's not there. So if you were going to pick that out, if this was your original, so it's 1 over 1. Well, you can look at this, that's just your slope. So now we have a slope of 5 over 1. Instead of 1 over 1, now it's 5 over 1. So let's make our new line, a new color. So we're 1, 2, 3, 4, 5. So it's going to rise 5 and run 1. So our new, and then we'll reflect it over here. So our new v is going to look like, well, something close to that, much skinnier. Okay, oops. Okay, for 17, we have y equals negative 1/3 times the absolute value of x. So now, not only do we have a compression because that 1/3 are a values between 0 and 1, we also have a negative sign out there which reflects it over the, which axis is it? It's going over the x-axis. So let's take a peek at what this does. So you're going to take that original equation, flip it. Well, actually, I would take the original equation first, and I would compress it. So instead of 1, 1, now we have a rise of 1 and a run of 3. So our new one's going to be out and then reflected over here. Right there. Okay, so our new is there. Okay, and I'll highlight the new one. There's the new line, the compressed line, so it flattened this original one down. And now we've got to reflect it over the x-axis, so it flips this way. So there's your new equation. 18, we've got y equals negative 3 times the absolute value of x plus 2. So now we've got a negative, so it's going to reflect over the x-axis again, and it's got a stretch factor of 3, the absolute value, which is that v, and then we're going to shift it up 2 units. So it's a reflection, shifted up, and stretched. So I would graph it first. So it's going to be like this, right? And then you're going to stretch it to a factor of 3, so it's going to get skinnier. I would now move up 2 to our new point, and then flip it upside down. Number 19 says, what's the graph of each inequality? So now we have 3x minus y is greater than or equal to 3. So what we need to do first is realize this is in standard form, and all I have to do is get my x and y intercepts, right? So if I turn y to 0, I get 3x is greater than or equal to 3. Divide both sides by 3, and you get that x is greater than or equal to 1. So actually when we solve for those, we need to put in the equal sign. So do that again. So to get your x and y intercepts, we're going to do 3x minus y equals 3. Now turn y to 0, and that goes away, and we get the x equals 1. So our x-intercept is 1. Now to get your y-intercept, now you're going to turn x to 0, so that goes to 0, and you get negative y equals 3. Well, divide both sides by negative, and you get y equals negative 3. So my y-intercept is negative 3. Now I can draw my line, right? And what are they saying? So what we need to do, we've got our boundary line, right there, and here's the actual graph down here, and there's the 1 that I graphed up here, and our negative 3, there's the negative 3. Now here's the actual graph, and we need to pick a test point, and I always say to pick 0, 0, right? That's easy to work with, 0 and 0. And we need to see if it makes a true statement. So let's plug it into our original equation. Is 3 times 0 minus 0. Well, 3 times 0 is 0, minus 0. So that's just going to be 0. Is 0 greater than or equal to 3? No, that's false. So you can say this point that we just picked is not in our solution set. That means shade the other side of the line. So that's how you figure that out. And because it's also equal to, it's a solid line. If the greater than or equal to had just been greater than, we would have done a dashed line. But because it has the equal, we make it a solid line, meaning that everything on this boundary line is included in our solution set. Okay, Number 20 says a doctor's office schedules 15-minute appointments and half-hour appointments for the weekdays. The doctor limits these appointments to, at most, 30 hours per week. Write an inequality to represent the number of 15-minute appointments and the number of half-hour appointments the doctor may have in a week. So we have to figure out first our equation and how to set it up. So we know that he's going to have 15-minute appointments and half-hour appointments. So we're going to set those up first. So notice that we have minutes here. Half hour would be how many minutes? 30 minutes. And then we have 15 minutes. And then we have 30 hours. Let's first convert everything to minutes. Well, 30 hours times 60 minutes per hour. Well, 6 times 3 is 18 with the 2 zeros, so it's 1,800 minutes. So the first thing to do is put everything in minutes. So this is going to be 1,800 minutes, 15 minutes, and the half-hour appointments is 30 minutes. Now, we can say, let the 15 represent X, the half-hour is Y, and our total hours per week is 30 hours, which is 1,800 minutes. So to set up our equation, we have to say, well, the number of 15 minutes appointments is going to be 15x plus the half-hour appointments, which we'll call 30 minutes times the number of appointments, y, right? That must be less than or equal to our 30 hours per week, which is 1,800. And there's your equation. Number 21 says, what is the graph of each absolute value inequality? So for the next three problems, and our last three, we have the first equation, 21, says y is less than or equal to the absolute value of x plus 2 minus 3. So it means we are taking the graph and we are shifting it to the left 2 and down 3. So we're taking this graph and we're going down 2 and to the left, I'm sorry, just did that backwards. Taking this graph and to the left 2 and then down 3. So our new vertex is going to be down there. Okay, and it's going to look like this. Okay, now how do you figure out the shading? Well, the first thing we need to do is look at the boundary line. Okay, it's also equal to, so it's a solid boundary line, so you will graph that solid V. And now you need to decide which side do we shade on, above it or below it. Again, pick a test point, pick 0, 0, and plug it into your equation. Is 0 less than or equal to the absolute value of 0 plus 2, which is just 2, minus 3, which is negative 1. Is 0 less than or equal to negative 1? No, it's not. So that's not the side that we shade. So shade the other side. So when it's false, shade the other side. Our test point was false, so he's not in our solution set. It means all of our solutions have to be on the other side. 22 says, write an inequality for the graph. Now we're reversing the process. They're giving us a graph and we have to write the inequality. Well, we have, it looks like a dashed line here. And so I'm going to say y equals mx plus b, right? And we have a slope of, let's see, these are all units of 1, so rise 1, 2, 3, 4, rise 4, and run 1, 2, 3, 4. So we've got a slope of 1. So we have y equals 1x plus, and what's our y-intercept here? It's a negative 4. So we've got y equals x minus 4. Now, we need to, it's not equal to, now we've got to change our inequality sign, right? So it's dashed. So it's either going to be greater than or less than. So what you need to do, let's look. It's shaded above the line, so this is a little shortcut and a trick that I use. So it is greater than x minus 4. And that's your answer. 23, we've got this one. So we know we've got that standard form of y equals absolute value of x. And what have we done? We've turned it into an inequality, and it's shaded underneath, so it's less than. And it's solid, so less than or equal to. And what have we done? We've shifted it from here. So we've gone over by 1, 2, 3, 4. So we've gone to the right 4. So it's going to be absolute value of x minus 4. And then we've gone down 1, 2, 3, 4, 5, minus 5. And there's your new equation. And that's everything, guys. That is our test, and study hard and do well. Thank you.